This tape simulates a Sencore service seminar which introduces the PA81 stereo power amplifier analyzer. Our audience members will be asking some of the most common questions about this new unit. So sit back and pretend that you're part of our audience as we learn more about this exciting new product. Hello, my name is Frank. I'll be your instructor today for Sencore's Audio Analyzer Clinic. Audio servicing can be one of the most profitable parts of your business, providing you have the equipment needed to service effectively. We're going to show you a new analyzer which can do exactly that with any amplifier problem. Let's start by discussing some of the problems that you run into every day. Now, isn't it true that you don't have much trouble making simple audio specification checks? Can't you pretty easily tell if an amplifier has too much distortion with your current equipment?
Sure, I use a general-purpose audio function generator and a dual-trace scope to look for clipping on the sine wave.
Well, I use a distortion meter to check the output, but there's dozens available, so I don't have a real problem there. Spec testing isn't really a problem.
So where do you have most of your troubles?
For me, it's the power amplifier stages.
Okay, the circuits convert the audio signal into power to deliver to the speaker, don't they? Now, how often have they caused you to practically pull out your hair as you look for the bad transistor or other part?
Yep, you're right about that. I'm afraid I won't have any hair left.
Let's see why amplifiers are so tough. Now, each stereo channel's amplifier has a differential input, a bias stage, 1 or 2 driver stages, and a push-pull power amplifier.
Yes, and some of those high-power jobs even have parallel output transistors to make things even more confusing.
So, Joe and Ed, what you are saying is that you really don't have an easy way to follow these signals through these power amplifiers. But what's the real problem?
They're direct coupled. It doesn't matter where the problem is, all of the circuits seem to be bad. You end up swapping parts, just trying to nail down the part that is bad.
Well, one channel is usually good and can be used as a comparison for the bad one. Now, what I'd like is a way to compare the signal from both channels simultaneously.
And I'd like to match the output to a load without having to jerry-rig a whole bank of resistors. I'm never sure whether my load meets the requirements called for in service literature.
You know, that really helps. You really need to deliver the power into a load in order for the readings at the driver and output stages to have any real meaning.
Okay, so you want good dummy loads. Now, let me ask this. Do you have anything that reads the power directly?
No, I have to use a voltmeter and then calculate the power based on the voltage readings and the load impedance.
Right, that's what I have to do too. Sometimes I give an amplifier check at 4 or 5 different power levels and then calculate each time.
We hear that story a lot. I like to show you what we call the missing link of audio servicing. It's designed to make amplifier testing easy, reliable, and to the specs of the Institute of High Fidelity and the Electronic Industries Association. I hope you don't mind if I shorten these mouthfuls to IHF and EIA for the rest of the meeting.
Yeah.
Sure.
Here's Sencore's PA81 Audio Power Amplifier Analyzer. It takes over where you say you have the most trouble, in the audio amplifiers. There's nothing like it on the market. Let's start with the auto-ranged watt meters. Unlike standard AC voltmeters that most technicians have to use to measure amplifier output, these are frequency compensated all the way to 200 kilohertz with 2% accuracy. All you have to do is read them directly to 200 watts per channel. Before I test the power, here's how you make the connections. Just connect each of the amplifier outputs into the dummy load connectors. The meters monitor the signal across the loads as selected by the first 4 steps of your function switch. The loads let you test the audio system at full power without that annoying howl of shop speakers. Let me tell you what makes these loads so special. They are a non-reactive loads specified by IHF and EIA. You can select any of the standard impedances, 2, 4, 8, 16, or 32 ohms. Each load will absorb a full 100 watts continuously to let you heat run any amplifier for as long as you need. And for those high-powered jobs, the loads can handle 250 watts for a full 5 minutes. And what's more, you can put the loads in parallel to test up to 200 watts continuously or 500 watts for 5 minutes on those musical instrument or sound reinforcement amps. The loads are air-cooled with this special fan in the back to prevent the load resistors from getting too hot and becoming inaccurate or burning up. And Robert, you said that you use a separate distortion meter. Just hook it in parallel with the PA81's dummy load input jack, which lets the PA81 soak up the power while your meter measures the distortion under full output.
That's great. I've always wanted to be able to check distortion at an amplifier's rated power, but I couldn't because my distortion meter doesn't have loads.
Well, some manufacturers want you to test the amplifier with an open load before connecting it to a load. Can you do that with the PA81 too?
Yes. Just move the IHF dummy load switch to the open position. The voltage and the dB functions of the meter still respond, but the amplifier is unloaded.
Could I damage the loads with too much power?
I suppose you could damage them if you really tried, but chances are you won't. The fan in the back carries away normal levels of heat. The warning light on the panel in front glows if the load resistors become too hot.
Is there any way to test amplifiers bigger than 500 watts?
What are you planning to do, make toast?
500 watts are loud enough for my customers.
I've never even seen an amplifier that big.
All right, calm down. Calm down. Robert has a valid point. It's true that 500 watt loads are sufficient for most applications, but some people need larger loads. For example, some auto sound systems deliver more than 1,000 watts. And what about those giant systems used for rock and roll concerts? Well, we've taken care of these needs too with this special accessory. It hooks between high-powered amplifiers and the PA81 to extend the range to a full 2,500 watts per channel, 5,000 watts total. It divides the power by 10, so all you have to do is add a 0 to the meter readings. So how are we doing so far, guys? Can you see how the PA81 simplifies power testing?
Hey, it's great.
That's great.
Wonderful.
Filters are needed for several test conditions.
Well, I've heard that, but I'm not sure why.
Here, let me play this short tape for you, which explains IHF filters.
The human ear responds to frequencies from 30 hertz to about 15 or 20 kilohertz. However, many high-fidelity amplifiers' bandwidth extend to 100 kilohertz or more. Noise in the ranges beyond normal hearing may add to meter readings. Filters eliminate questions caused by those added signals and also give you a way to tell if they are present. First, when testing an amplifier's frequency response with a good generator, don't use a filter. Use the decibel meter scale and determine the response directly. You need filters to tell whether hum or noise are included in the amplifier output. Here's how this is done. Hum from power supplies or ground loops may mix with your test signal. Hum filters use a cutoff frequency of 200 hertz to include both 60 hertz power line interference and the 120 hertz frequency from a full wave power supply. You find the amount of hum by comparing the meter readings without filters to the readings with the hum filter switched into the meter circuit. The difference is the amount of signal added by the hum. You use the other filters in a similar way to find high-frequency noise. There are two common sources of noise. First, many FM receivers let some of the 19 kilohertz pilot pass to the speakers. Second, the digital clock used in compact discs may add to meter readings. This clock runs at 44.1 kilohertz. 4 filters take care of these tests. The first has a pass band from 200 hertz through 15 kilohertz to test power in the audio band without added signals causing false readings. The second filter blocks frequencies below 200 hertz to find hum. The third filter is a low-pass filter with a cutoff frequency of 15 kilohertz to block the FM pilot. The fourth filter is a low-pass filter with a cutoff frequency of 30 kilohertz for use with CD players.
Now do you see why you don't always want a flat meter response?
Yeah, I've tried to build some of those filters and hook them ahead of my speaker loads. Do I have to do the same thing with the PA81?
No, they are all built into the PA81. All you have to do is move this switch, which is called the IHF input filters, to the correct position. Now, isn't this a lot easier than building your own filters and patching them in and out of your measuring setup?
Dummy loads are nice most of the time, but sometimes I'd like to listen to the amplifier while I'm making the tests. Do I have to disconnect the PA81 and hook up my old shop speakers?
Yeah, and when you do that, the speakers blast at full power. You can hardly stand to be in the same room. Now, isn't there a better way to make those tests?
Yes, and the PA81 satisfies both of these needs. First, to answer Joe's question, no, you don't have to disconnect the PA81 to hook up speakers. The PA81 has its own test speakers built in, and if you prefer, you can plug in headphones so that only you are hearing the test signals. And Robert, your question about high power levels is answered too. The volume from the PA81 speakers is adjusted separately. You can put in several hundred watts and adjust the speakers for a low listening level. The PA81 even limits the power fed to its speakers to keep the volume within a fixed range. You never have to worry about blasting out your ears or those of someone nearby.
That's just what I need. My landlord's threatened to have me evicted in the past after testing some of those big power amps. Now I can let them run for hours at a time and only I can hear the signal.
Frank, I see the PA81 has analog meters. Why didn't Sencore use digital readouts?
Joe, some measurements are just tougher to do with digital readouts. A good example would be to compare left and right channels for equal output as you adjust the output power from minimum to maximum. The high-quality d'Arsonval meters we use actually cost nearly twice as much as digital displays, but they give much better results. The meters are auto-ranged so that you don't need to worry about ranges. These red LEDs tell you the range. The range switches give you the option of manually overriding the automatic circuits when you want. But most of the time you'll find that you get the best results by leaving the meters in their automatic mode.
Yes, I agree. Digital meters would be dancing all over the place. But sometimes I like to monitor the output with my scope at the same time I'm measuring output power. Do I have to find a way to strap that across the load jacks?
Ron, do you see these two jacks called two-scope input? These are specially compensated jacks that let you connect directly to your dual trace scope or Sencore waveform analyzer. Just like the speakers, the automatic ranging circuits keep the signal feeding to your scope within a limited range so that you don't need to switch your scope attenuator very often.
Hey, great. I can already see how this can help me find amp problems faster than I can now. I can find out which channel is low and which has hum or interference.
Yeah. Frank, I can see how the power meters, filters, and loads work together at the output. But how does the PA81 help if I suspect a problem back at the preamplifier or driver stage?
Yeah, there's a real problem there. And don't forget, the direct coupled stages affect every reading right up to the push-pull outputs.
Joe and Ed, you've really hit on a key feature of the PA81. First, I must point out that the dummy loads maintain a constant load at the output while you move back through the circuits. When you switch the function switch to any of the positions marked in blue, the meters receive their inputs through the two external input jacks, also marked in blue. These inputs are also auto-ranged with manual override if you want. There are 4 switch positions marked in blue. You can read the DC or AC signal level in RMS volts, decibels referenced to 600 ohms, or programmable decibels referenced to any signal level. The first position lets you measure the RMS voltage at any test point. The PA81 lets you measure all the way from 100 microvolts to a full 200 volts RMS and 6 auto-range steps. Watch as I move through this demonstration amplifier. I'm reading the level here at the volume control. Notice that the meter reads 8 volts. Here I'm connected to the preamplifier input. Now the meter reads 3 volts.
Some of my service literature shows the output in decibels instead of in voltage. Now, how can the PA81 help me in testing those circuits?
Sure, that's common in professional audio gear. The PA81 has 2 decibel functions. The first makes every reading in dBm reference to 600 ohms, which is the most commonly used audio reference. You can compare these readings directly to the service literature that shows dB levels. But if you don't want to add or subtract, switch to the dB programmable function. Press the dB program reference store button to 0 the meter at the first test point. Then move the probe to the next stage. The dB scale shows the gain or loss compared to the first test point. Can you see where this might speed up your service work?
Speed it up. You practically eliminated it. Anytime you can prevent calculations, you've automatically reduced errors and wasted time.
What about giving us some help with the direct coupled stages, where you have to find a bias problem before you can even worry about audio?
Good point, Joe. All you have to do is switch to DC for 2 matched meters. You can compare the DC reading in one channel to the other simultaneously.
I should have known. Yep, this is a Sencore design. But let's get back to troubleshooting for a minute. Sometimes the problem isn't in the amplifier, it's in the CD player or the tape deck that feeds the amplifier. How does the PA81 help me there?
It's a good idea to check those sources, Joe. That is why the PA81 has two audio line input jacks. They have a standard 10 kiloohm load for accurate testing. Simply connect your audio source and switch the function switch to one of the three positions marked in gold. You can measure the RMS level, the dB level referenced to a milliwatt into 600 ohms, or a programmable dB level referenced to any signal you like.
Okay, the meters let you measure signal at either the external input or the line inputs. But how can I tell if they're reading signal and not just circuit noise?
Well, I'm glad you asked because I forgot to mention an important benefit a minute ago. Do you remember how the internal speakers monitor the signal applied to the dummy loads? Well, guess what? They do exactly the same thing for the external troubleshooting input and for the line input too. Watch. I'm going to connect the troubleshooting probe to the base of the driver transistor. Now, listen while I turn up the volume control on the PA81. This tone is a signal picked up by the probe at the driver stage, not the amplifier output.
Wow, that's great. I can measure the signal with the meter, view the waveform with the scope, or I can listen for the signal through the speakers as I move the probe through the circuits. Now, what else could Sencore have thought of?
I've got just the thing for you. The auto-ranging circuit constantly adjusts the volume level for you too. They amplify weak signals and attenuate strong signals in 6 steps. That way you don't blast yourself out of the chair when you connect to a test point with a high signal level.
Frank, I can see where these features will let me improve my audio profits. But I got a problem I doubt even Sencore can help me with. I mean, can your unit help me find intermittents?
Good point. Sometimes an intermittent wipes out all the good parts you just installed. Now, can the PA81 help prevent all those damaged parts?
It may sound too good to be true, but the PA81 can help in both of these cases. In order to understand, you need to know why an intermittent failure can cause replacement parts to be damaged. This videotape will explain what's happening inside the amplifier.
Modern high-fidelity amplifiers are often direct coupled from the input right up to the loudspeaker. Direct coupling means that the output of one transistor connects directly to the input of the next transistor stage without DC blocking capacitors in between. Direct coupling helps the amplifier produce the same gain through the entire audio band. Blocking capacitors would make low-frequency gain difficult. But direct coupling adds a problem. The DC bias of each stage depends on the correct bias in the preceding stage. When everything is balanced, the net DC voltage of the output is 0 because the DC bias on the top side of the push-pull amplifier is exactly equal and opposite to the DC bias on the bottom stage. If the bias becomes upset, the resulting current flow may cause distortion or may damage components at higher levels. The DC current flows directly through the loudspeaker and its crossover network. This can ruin the speaker's voice coil, or it may cause the circuit breaker or fuse in the speaker to open. If the amplifier is unbalanced and the speaker load remains connected, the DC current can ruin one of the output transistors. This in turn draws too much power through the driver and pre-driver transistors, causing them to fail too. These so-called avalanches can ruin every transistor in the amplifier in less than a second.
I thought I was safe from avalanches because I don't ski.
Yes, that's exactly the point I was making. Frank, what can we do about those expensive avalanches?
Robert, take a look at these two lights on the PA81. They are part of an innovative DC balanced test circuit. The PA81 constantly monitors both dummy loads for a DC offset. If either shows more than 1 volt, the light comes on to tell you which channel failed. The internal dummy load is immediately disconnected until you manually reset the circuit by pressing this button.
I see. Disconnecting the load prevents further damage and stops the avalanche.
Yes, and remember that one bad part can damage many others. The PA81 can prevent more components from being damaged.
It seems that would help find intermittents too. Tell me more about that.
Well, there are a couple of ways this can help. First, if the DC balance goes off as you increase the signal level from your test generator, you'll see it instantly. Or you can hook up your test generator and let your amplifier cook for a while. If you come back later and find one light glowing, you know which channel is bad.
Does a DC overload mean the output stage is defective?
No, it only means that that channel has a problem. Keep in mind, Ed, that direct coupled circuits mean faults in the driver or input stages will upset the power amplifier biases as well.
That feature will really help me track down those intermittents.
Frank, I like the meters in the old Sencore SG165 for separation tests, but now I find they don't have enough range for the new receivers. Does the PA81 improve these tests?
The SG165 was pretty handy. It easily let you measure 30 decibels, 40 with some estimating. The PA81 does much better. It measures all the way to 126 decibels. What's more, you may not have realized that the SG165 meters were only accurate at the 400 hertz frequency supplied by its internal generators. The PA81 meters are flat from 20 hertz to 200 kilohertz. Does that cover everything you'll run into?
You bet it does. And it's auto range, too. You know, these tests will really move me through those tough dog service jobs.
That's a full-fledged power performance tester that I can point to with pride as I'm thoroughly servicing my customers' stereo systems.
And I do a lot of auto radio work, and I do some work on PA systems in large buildings. It sure would be nice if I could take the PA81 tests right to the trunk of the car or to the end of the PA line.
Ed, the PA81 is 100% portable. It will run from 12 volts or from its own internal battery. Just install Sencore's optional BY234 rechargeable battery and run it for 8 hours on a single charge. And what's more, if you forget to turn off the PA81 when battery powered, it will turn itself off after 20 minutes of use. Now, how's that for thinking of your portable use, Ed? Now I would like to mention one last benefit the PA81 includes. The internal microprocessor can work with the computer through Sencore's innovative instrument control port. You can make the PA81 part of an automatic setup by using either the IEEE 488 general purpose interface bus or the RS-232 serial communications.
Okay, you've really shown me that this unit can help me with the worst problems that I face in audio service. But how much do I have to pay for all this performance?
Well, Joe, it may not be as bad as you might imagine. Let's just see how much you would have to pay if you were to buy all the functions and features from competitive outfits. Now, no one makes an integrated analyzer like the PA81, so we'll need to add up all the separate pieces that you would need. First, you would need 2 highly sensitive, accurate, out-of-range, direct reading watt meters. These would cost about $700 each for $1,400. Next, you would need 2 auto-ranged RMS and dB meters with programmable dB. Very conservatively, that is $500 each for another $1,000. Add to this 10 250-watt IHF EIA non-inductive load resistors at about $50 each, and you have another $500. Add 2 test speakers, earphones, and isolated control circuits for another $50 each, or an added $100. Add the built-in computer control bus, which works with either the IEEE 488 or RS-232 computers, and you have at least $300 more. Finally, let's add the extras, like the intermittent circuit monitor at $150, the audio line testers at $200, and another $200 for interconnecting circuits to prevent that mess on your bench. Bring all the pieces together and you have the missing link in audio servicing that the PA81 represents. The total comes to about $4,300 in equivalent separate testing devices. The price of the PA81 is not $4,300. It's not even $4,000. It sells for a reasonable $1,995 with Sencore's full made-right lifetime guarantee. Now, a guarantee like that's really important for a high-powered instrument like this.
Well, that is a fair price for all you get. Besides, I know that I can spread the investment out with the Sencore pay-as-you-grow payment plan. But it would be nice if I could count on the unit generating extra income, as well as the help it gives me in my troubleshooting. Any ideas there?
I'm glad you asked. Yes, This is more than just a time saver. It is also a business builder, if you promote it correctly. First, let me ask you all a question about how much you charge for your service. How many of you charge exactly the same amount, no matter how much or how little work you do for your customer?
No, you can't do that. You have to charge more for the complicated jobs than you do for the easy ones.
Sure, because if you don't, you'll lose your shirts on the tough jobs, or you'll overcharge on the easy ones and send all your business off to the competition.
Okay, so you have to charge according to the services that you provided. But how do you know how much is right?
I itemize my bill. You know, so much for checkout, so much for repair, so much for alignment.
Yeah, that works for me too.
Good. That's how most profitable service companies do business. And that's where the PA81 can bring a brand new service that you can provide your customers that they cannot get anywhere else. The PA81 lets you do a complete performance test. You can do your test before you do any of your repairs with your customer watching as you and they agree on the symptoms. Then, to wrap up your job, you can do a final check before returning the unit. Would you be willing to charge at least $5 if the performance test was made in your shop and $10 if made in an automobile or a remote spot? Those two average $7.50 per test.
That's fair as the dickens, I think.
Right. It sure works for me when I perform AC safety checks with my PR57 PowerRite. It automatically adds $3 per invoice, and my customers actually thank me for thinking of them.
Fine. Let's run some estimates on what this can mean for your business. If you owned a PA81 right now, you could start charging an average of $7.50 per performance test. Now let's say you work on 4 audio jobs a day. The performance test alone brings you an extra $30 a day income.
And that doesn't even include the extra audio business I bring in that I'm not bringing in now.
Frank, you pretty well convinced me that the PA81 is the missing link in my audio servicing. My competitors will be making those profits in audio servicing if I don't. I'm losing money every day that I don't have one.
Well, I don't see much competition in my business. But I can see how the PA81 will help cut losses in troubleshooting and wasted parts.
And I can see where I made testing errors in the past by not using EIA-specified filters in testing, or not using non-inductive load resistors with the correct impedance.
Great. Now, let me make a quick recap before we end. The PA81 provides direct reading watt meters which measure directly across the IHF standard dummy loads. The fan-cooled load bank lets you measure 100 watts per channel continuously or 250 watts per channel intermittently. The IHF filters let you quickly learn whether a signal includes unwanted hum or high-frequency carriers. You can monitor every signal 3 ways: with the built-in meters, with your dual trace scope, and with the monitoring speakers so you know exactly what you're testing. Then the troubleshooting probe and line level test inputs let you move back from the speakers right up to the signal source to trace every problem, DC or AC. You can compare left to right channels every step of the way for even faster troubleshooting. You have the choice of RMS, decibels referenced to 600 ohms, programmable decibels, and DC to pinpoint any problem. Then the exclusive DC balance test with automatic load removal lets you find intermittence while protecting the amplifier circuits. Finally, the ability to measure to 126 decibel separation lets you work on the latest units, no matter how high of performance they provide. The PA81 is a real business builder, and it's sold with Sencore's solid 30-day proof of performance guarantee to give you plenty of time to decide whether it will do the job you want. Simply stated, I'm sure each of you have different reasons for wanting the PA81. Thank you for attending the Sencore audio seminar, and I hope to see you next time.